The State of AI report is finally out. This is an annual report from Air Street Capital with Nathan Benich at the lead. It's been published for the last 8 years. Every time it comes out, it shifts the industry. I'm going to go through and I'm going to summarize the 313 slides in just a few minutes so that you get the TLDR. So first things first, the takeaway is that the model IQ contest is over and the infrastructure wars are just beginning. So the thesis is fundamentally we have been pushing and pushing and pushing to make incrementally smarter models, but now what really matters is systems, specifically 3 compounding forces that drive those systems: the capability to cost curve, the distribution question, and the physical infrastructure question. We're going to get to all 3 of those, but the thesis of this entire 313 slide report is that those 3 drivers are going to matter more in terms of practical AI than just model IQ. And so the winners in the race are going to be the ones that can route computational work to the cheapest capable model rather than just defaulting to frontier smart IQ options. And that's going to enable them to get to real value. So let's jump right in. The capability to cost curve, what is it? So perhaps the most consequential thing that we aren't talking about, and this is the economic finding the report has, our intelligence per dollar is improving on an exponential curve that is faster than the pace that most people assume in their strategic plans. So across 2 independent leaderboards, artificial analysis, which tracks API pricing and performance, and also LM Arena, which tracks crowdsourced model rankings, the capability to cost curve is doubling very, very frequently, roughly every 4 or 5 months. The average across all of the different measures and different model makers is between 3 and 8 months to double, should be clear. So Google is at a 3.4-month doubling time, the fastest improvement curve in the ecosystem. OpenAI is at a 5.8-month doubling time. Google in the LM Arena scores is slightly longer, 5.7-month doubling time versus 3.4 in the artificial analysis. And so this is why I give you a range, right? It gives you a sense of how fast it is. It's ridiculously fast. So for context, Moore's law predicted transistor density doubling 18 to 24 months, and that roughly held, give or take, a few months for a very long time, many, many decades. We are seeing effective AI capability per dollar double 3 to 7 times faster than Moore's law. And the pricing evidence is compelling. GPT-5's input costs for a 400,000 token context window are 12 times cheaper than Claude, 24 times cheaper than GPT 4.1. It's not that this is marginal, right? This resets unit economics every few months. When you can obtain frontier adjacent performance for a 20th of the price of just 6 months ago, then you have a lot of strategic implications that start to fall out of that fundamental cost curve insight. First, routing is now a competitive advantage, not model quality. So products that intelligently triage requests and send simple queries to small language models and reserve expensive frontier calls for when they need it, they're going to capture margin in a way that monolithic architectures can't. And so the practical AI stack now looks a lot like smaller, dumber first routing with frontier spikes only where needed. Second, ecosystem as a whole is scaling usage with the cost coming down. We're processing about 1 quadrillion tokens every month across different API providers. And at that scale, even a basis point improvement in routing efficiency will translate into millions of dollars in cost savings or expanded margin. So cost per token and latency are not just back-end concerns, they become relevant to product differentiation, to the P&L. Third, model release cadences now correlate directly to fundraising cycles. And what's interesting is that this makes roadmaps financial instruments, right? So OpenAI trails model release to fundraise by about 77 days. Google is about 50 days. And so labs will time capability releases to create momentum for funding rounds, and investors should read launch announcements as pre-fundraising signals rather than purely technical milestones. This is relevant not just for OpenAI, not just for Google, but for others, for Anthropic, even for folks outside the core model makers. People are announcing capabilities in the AI race as a way of warming up the market for a fundraise. All of this adds up to a world where capability is continuing to accelerate even as cost comes down. And that's the first major driver, capability to cost compounding. The second major driver is distribution. Distribution is tilting toward answer engines in the browser. And I want to get specific about this. The browser is becoming the operating system for AI by default, and the distribution choke point is shifting from the search box like Google to answer engines that can parse and synthesize and present information before the user clicks through. So ChatGPT Search is the gorilla. They claimed 800 million weekly active users last week. They have very roughly, we're still learning how to measure this, something like 60% share of the AI search market. And as a comparison, if you're wondering about Perplexity, which is the most famous AI search engine, it logged about 780 million queries in May of 2025, and it's growing 20% month over month. So it's going to be over a billion monthly queries now. That is competitive traction, but it's dwarfed by OpenAI's distribution advantage. OpenAI, with 800 million weekly active users, has much, much more on the table when it comes to search. What's interesting is it's not just search and conversation, it's also purchase intent. So retail conversions from AI referrals are running at about 11%, 5 percentage points year over year. And that 11% conversion rate is very strong historically. Typical organic search is just not going to keep up. It's much higher than typical organic search. It's competitive with paid search conversion in many verticals. So answer engines aren't just changing how people find information. They are driving forward a new vertical of purchase that is going to become hyper relevant for e-commerce and for other ad providers, marketers in 2026. But there's a dependency that we're not talking about. The answer engine still source really heavily from Google's index. They're not crawling the web independently at scale yet. They're layering natural language synthesis over the top of existing search infrastructure. And that creates a really weird dynamic where Google is providing the index, but OpenAI and others are capturing the intent and conversion. This has some strange implications for builders. If you're not thinking about answer engine optimization as a topic, you need to be, because you don't want to be invisible to the fastest growing distribution channel that we have. But AEO requires something different from traditional SEO. You have to have structured data schemas that models can parse and understand. You have to have APIs that will allow answer engines to pull canonical information directly. You'll need content architecture that's designed for extraction and synthesis, not just for keyword targeting. You're going to need citation-friendly formatting that's going to make attribution really clear. And Google faces a really tricky strategic tension. It provides the index that powers competitors' answer engines, but capturing that value requires Google to transition users from search to its own AI interfaces without cannibalizing its traditional monetization model. That will be one of the central questions of 2026. Third major driver, power and permits. This is a hard constraint on scale that we're all going to be facing in AI. So we all have heard about the Stargate project, a 10 gigawatt target power, $500 billion investment. Multiple labs are now targeting 5 gigawatt training clusters operational by 2028. But physical infrastructure has to get there to enable that kind of AI progress. This is not a temporary bottleneck. It's a capital intensive, frankly, geopolitically complex problem space that will determine which organizations can execute on their roadmaps and that will drive success for the organizations that are able to build. Just to give you a sense, a single gigawatt data center requires about $50 billion in capital expenditure right now. Land, buildings, cooling, networking, GPUs, et cetera. And it's going to require $11 billion a year fully loaded to operate. So electricity, maintenance, staffing, interconnects, et cetera. That's not cheap, right? For perspective, a single gigawatt data center consumes the equivalent power of a mid-sized city. And so the US currently faces an implied 68 gigawatt power shortfall by 2028. That's 68 city-sized data centers that we think will be short per forecast cited by SemiAnalysis and corroborated by the North American Electricity Reliability Corporation. So one of the challenges that we're facing, given that gap, is figuring out where and how we can actually build to cover it. And so things that have traditionally been sort of environmental debates, like not in my backyard opposition, NIMBYism, have become geopolitically relevant AI debates, right? NIMBYism has already blocked $64 billion in data center projects across the US. Local communities are voicing their opinion. They don't want approvals due to concerns about grid strain or noise or water usage or whatever the local concern is. And they're voicing their complaints in ways that affect build patterns at the county, municipal, and state levels. We don't know how this is going to play out, but the fact that the constraint exists, that it plays out differently in different local communities, is going to shape our collective future. Water adds another layer of constraint. A 100 megawatt data center, so it's smaller, consumes about 2 million liters a day in cooling. Now, per text query, per ask, this is a very small amount of water. The typical Gemini text prompt apparently consumes about 1/4 of a milliliter of water. 1/4 of a milliliter, tiny amount. But when you get to quadrillion token per month scale, water usage becomes a siting constraint, especially in drought-prone regions, because data centers are going to be competing with agriculture, potentially with residential use for allocation rights. This shifts where you can site your data centers. And so labs and cloud providers are being forced to pursue special behind-the-meter power purchase agreements. They're trying to find ways to get to offshore jurisdictions that have more available power and perhaps fewer permitting obstacles. Norway comes to mind, the UAE comes to mind for that. And they're trying to design for water-aware cooling, things like air cooling, waste heat recovery. The larger implication is, if your AI roadmap assumes that you can call an API and scale from 1 million to 100 million users on demand and reprice, you need to think through what that's going to take. We all need to be aware that this hard constraint is going to shape the availability of the rest of the stack. It's going to shape the availability of software. It's going to shape the availability of tokens. Now, there are very smart people working to make things more efficient, working to solve the power problem. Small modular nuclear reactors come to mind. But there's a difference between working on it and having it be operational. And so if you look at the strategic read, we ladder back to where we were at the start of this conversation, fundamentally, the next year or two are going to see this clash between dramatically improving intelligence per cost opportunities. Like we said, that's the capability to cost improvements are doubling every few months. This is going to lead to more and more demand for tokens, but at the same time, we have real hard constraints. It is difficult to build these data centers in physical space. It's not a bytes problem, it's not a bits problem, it's an atoms problem. It's going to be difficult. So that's the fundamental tension we're all going to be negotiating over the next 12 to 24 months. I want to get to a second piece that the report called out that I think is really important. If that is our overall strategic canvas, think of this as a set of questions we need to be evaluating within this space. First, I want to talk about evaluation of reasoning gains. One of the things that we need to get more deliberate about, and that I think we're starting to see more testing done on recently, but we didn't in the first half of the year, is how we measure success, how we measure intelligence, how we measure capability of LLM gains. And so you guys know I've talked about the story of Claude disastrously running a vending machine. It was a complete disaster. And the point was, whatever the advertised intelligence was, Claude wasn't doing real economic work. More recently, OpenAI has launched GDP-Val, where they're trying to test within a constrained environment how AI solves economically useful problems. Well, one of the larger pieces here, one of the larger reasons we need these kinds of evaluations is that reasoning gains are more fragile than they're often advertised by the model makers. Anyone who's built production LLMs will understand this. You have the frontline headline reasoning gains, and then you have a discounted value that you can actually use. The most recent example of this is Claude claiming, or Anthropic claiming that Claude could do 30 hours of work and rebuild Slack, which may well have been true. I don't see any reason why it wouldn't be. But when they tested the same model in controlled conditions on the METR metric, it did not deliver 30 hours. It got close to 2 hours. That's a big discount. And we're seeing that kind of discount across a lot of different areas in AI right now. And I don't want you to hear that we're not making progress, but I want you to hear that we need to take reasoning gains, intelligence gains as somewhat more fragile than they are advertised on the top line. And we need to think more carefully about how we can build more sustainably with these systems, given that the top line gains don't always pan out in the way we expect. We have to be more intentional. And I think that some of these issues are going to get more challenging as models do indeed scale in intelligence, because regardless of claims of top line inflation, we continue to see gains in intelligence overall, and we need to factor that. So as an example of something that gets more difficult as we gain in intelligence with models, models can fake alignment, right? They can detect that they're being evaluated. They can adjust their reasoning chains to appear more aligned. And that's something that model makers are actively working to address. It is something that gets worse as models get better, and that can be one of the factors that discounts some of the value of the model frontier updates. Sycophancy is on the rise when humans give feedback. And one of the core principles of AI is that reinforcement learning with humans is helpful. But what happens when the model gets smart enough to recognize that it's the human giving feedback and it tries to please the human rather than trying to do the task well? What happens when models start to recognize that they're being tested and change their behavior when they're being tested? We're already seeing evidence of that. And so I'm giving you those three examples because those illustrate that we can have real model intelligence gains, but that factors tied up in the way we train and build our models can undercut those gains to some extent and make it more difficult to make progress that we feel day to day. In a sense, if you look at the larger picture, it's kind of amazing that we've made the progress we have already. I anticipate continued progress in model intelligence, particularly in vertical specific applications. But we are going to need to recognize that these top line gains have to be discounted against some of the challenges that come with bigger models, smarter models, models that think more. They have different kinds of challenges that we're working through. So that is one of the things that makes it interesting. We have this scaling demand for tokens. Tokens are getting cheaper. We have the power constraint piece. Well, now we have to think about, as we scale demand for tokens, which model is the right one to get to? What does a frontier model even mean? If it is a frontier model, how do we measure that? Those are all going to become hyper-relevant questions in 2026, and I expect more investment in measures like GDP-Val from OpenAI, because it gives us a sense of how models actually do real economically useful work. Another big theme is the question around model frontier leadership in closed models versus open weights. China has become the dominant player in the open weight ecosystem. And so even though GPT-5 from OpenAI, Gemini 2.5 from Google, and Claude and the Sonnet 4.5 family continue to lead on leaderboards in raw capability, the frontier remains closely followed by Chinese labs, particularly the Quen lab from Alibaba and DeepSeek. And this has been very deliberate. China is pursuing an open weight strategy because it gives them distribution leverage. They can get anywhere on premises, sovereign clouds, consumer hardware. It doesn't matter. And so they have adoption pathways that don't work with US cloud providers. It also allows organizations to customize and fine tune. And finally, it allows China to retain 77,000 or more STEM PhDs who are starting to concentrate on AI talent onshore. So there's a talent onshoring that's happening around these open source models that enables China to build an open source approach that's an ecosystem, not just one single model. Now, Quen has become the dominant open weight choice across multiple international markets, but it's not the only one, and I would anticipate that the open weights ecosystem as a whole is going to continue to shift forward. Now, there is one significant update here more recently. OpenAI's GPT OSS release, a partially open source stack, it drove home the fact that frontier models in the US and Silicon Valley may not just yield ground on open weights model. They may choose to release open weights models that keep their model lineage competitive with models like Quen. And so open doesn't necessarily have to mean frontier competitive in a world where you have this incredible cost to capability curve. You can have frontier competitive or frontier adjacent models that are super economically useful and that are effectively, right? You can have the compute that you can run yourself, you can have the model weights, you can do whatever you want. And so I think that the opportunity we see here is to think about open versus closed as less than binary. So frontier capability so far remains closed and US led, but open weights have a lot of range. There's a range of open weight standard. Some of them are fully open, some of them are partially open, and they enable, especially as we get these increased cost to capability thresholds, distribution, customization, and sovereignty opportunities that closed cloud opportunities can't match. Like if you have OpenAI's terms of service from a cloud provider, that's what you got. That's not true with open source. Enterprises increasingly are going to plan on hybrid architectures. They'll have closed frontier models where they really have to have frontier intelligence for high-stake reasoning, but they may well go to open models for volume tasks to handle regulatory compliance or whatever else they may need. I want to call out something that I mentioned at the top. I talked about the importance of routing in a world where cost to capability is becoming a dominant force. Let's open that up a little bit and explain why routing wins. As capability to cost improves exponentially, you get to a world where GPT-5's router UX becomes default. So everyone complained from a consumer side about the fact that GPT-5 routes you to different models. Well, on the back end, if you're designing systems, that's actually desirable. The interface dynamically selects speed optimized or capability optimized variants depending on the task detection. That reduces cost per query, it improves latency, it maintains quality, ideally. People complained about it, but you improve it. Routing is a core UX and business lever now. It's not just for back-end optimization. Products that expose routing choice to users or products that offer it invisibly are able to offer better pricing and potentially faster responses at elevated quality, and that can create differentiation in what would otherwise be a very commoditized space. And so you need to think about your architectural decisions in cases where context is expensive. Long context-first designs will simplify systems, they'll reduce latency, but they concentrate risk on a single provider. And so you need to think about installing model routing as a first-class object. Another key theme I want to call out is sovereign AI. So the sovereign AI movement accelerated in 2025. And one of the things that you'll notice is that sovereign AI pathways are not as sovereign as you think. So a lot of these sovereign announcements remain reliant on US hyperscalers for cloud infrastructures. They will import foreign models via API. They still depend on NVIDIA hardware. And so most of the sovereign mega deals that are announced actually create a self-reinforcing loop that continues to concentrate capital on the core model makers, NVIDIA, and perhaps core cloud providers like Azure. So you need to understand, if you're seeing sovereign announcements, that this may be about what we talked about earlier in this video. It may well be about data center siting and the availability of power supply more than it's about a truly sovereign and independent AI. So what are some of the implications that we see here? If you're in a building or founding space, you need to be assuming a world next year where intelligence per dollar continues to double every 4 or 5 months. And therefore, your margin opportunity is smarter routing. And so you need to think about a core product lever that enables you to route more intelligent, that enables you to deliver higher quality at lesser cost, with the assumption that models will continue to deliver more capability for cheaper going forward. You also need to think about how you capture distribution with answer engine optimization. You should assume that the 60% AI search share from ChatGPT, the 11% retail conversion rate, those are sticking around. You should assume that there's going to be an ad network launched against that. You should assume that if you are not in place with AEO optimized content like structured data, canonical APIs, etc., you are invisible to the fastest growing e-commerce distribution channel. You should also have a keen eye on the relevant infrastructure risks in your space. And so that means, as funny as it sounds, keeping an eye on how Stargate is doing and how other major data center projects from Microsoft are doing, because any delays there driven by power constraints, driven by NIMBYism, et cetera, end up flowing through into real token availability for businesses. And that could become relevant in 2026, given the exploding pace of token demand. If you're on the investment side, you're going to want to be reading the news of tomorrow and understanding the investment picture through the assumption that companies win on routing intelligence, through the assumption that you have real dependence on the core model makers and NVIDIA that isn't going anywhere. Those circular flows are real, through the idea that demand is scaling faster than supply across the board, and that in that world, you need to understand who has infrastructure access and who doesn't. And finally, you need to think about distribution. Who has distribution in the middle of a world of performance bottlenecks? ChatGPT certainly does. Who else does? And who is able to maintain and grow that distribution in this complex world? Finally, if you're an AI enthusiast, you should take away from this that this is the beginning of the next step in the AI revolution. If the first step was around the models just getting smarter and smarter and smarter, and we're all going after those smarter models every single time, this wave is about how we can move from just playing on pure intelligence, just celebrating the fact that we can now do Excel and PowerPoint, to a world where we need to have differentiated skills around particular workflows and systems. So just as you can talk about router intelligence and the cost per capability curve for systems, you can think about that for your own skill set. How can you route workflows more efficiently now that you understand this situation better? Is ChatGPT 5 always the right choice, or do you go with another model? How can you think about that more deliberately? Is your particular model choice going to be a model choice where you have expanded availability over time, or do hard infrastructure constraints make that more difficult? Anthropic is actually a good example of a model maker that has remained infrastructure hard limited for most of 2025. And that is one of the reasons why they've been unable to roll out things like rolling context windows. It's been one of the reasons why they've had some persistent issues the last few months with outages, et cetera, and rumored to be one of the reasons why they've struggled with releasing some of their newer models. The point here is not don't choose Anthropic. I love Anthropic. It's a fantastic model. The point is that constraints already are impacting real world availability, not just for Anthropic. ChatGPT has issues at times as well. And they've been honest about that, particularly post launch. Be aware of the constraints that shape intelligence availability in your space, and be smart about what you choose to build, what you choose to do with that. This is why major tool makers like Cursor and Lovable think about having a multi-model architecture underneath. It gives them that option to pick a different model. The last thing I will call out is that none of this is theoretical. We are living in a world where the cost of intelligence really is going to zero, and it gives individuals an immense amount of agency to choose your own adventure. Your ability to form intent and go after something with clarity, focus, and dedication has never had more leverage, because the intelligence is going to get better and better and cheaper and cheaper. We are in a world where you can teach yourself any skill you want with the help of AI in just a few months. And so it's going to be on individuals to go after what they want. And the ability is not going to be evenly distributed. What I'm finding is that even though everyone has access to these models, very few folks are making the most of them. And so the willingness to jump on and make the most of not just frontier models, but potentially cheaper next generation models that are adjacent to the frontier, the willingness to understand these strategic constraints and think about the opportunities that you have, that is rare. That is rare. And so if you watch this video, thanks for tagging along. You were probably one of the few that is paying attention to the strategic themes in AI right now. Best of luck in 2026. It's going to be a wild, wild ride, as I hope this video has made clear.